Oh, yikes. Okay. Hey guys, this is the homework 5 number video, or homework number 5 video. I'm sorry for the start. I had been trying for like a minute to figure out how to start the recording, but it did start, so here we are. So let's get started. So looking at the IB textbook problems, we have the sequence 13, 19, 25, and we're supposed to find the 10th term in the sequence by extending the pattern. So I'm going to write out my blanks, 1, 2, 3, so we know it's 13, 19, 25. You don't have to write it out this detailed. This just helps me because I have a really hard time counting if I'm under pressure, which is what I would consider this video. So let's start. We have 13, 19, 25. We know that we can find our common difference by figuring out what the pattern is. I see that I'm going to add 6 each time, and I found that by taking 19 minus 13, which I'm typing into my calculator to double check to make sure I'm right, which is plus 6. So good. So we have 13 plus 6 is 19. 19 plus 6 is 25. So next we're going to do 25 plus 6, which is 31. 31 plus 6, which is 37. 37 plus 6, which is 43. 43 plus 6, which is 49. 49 plus 6 will give me 55. 55 plus 6 will give me 61. And 61 plus 6 is 67. So my 10th term is going to be 67, which I found by adding 6 each time, starting from 13 all the way to the 10th term. So now I'm going to find the 10th term of the arithmetic sequence using the formula. My formula is right up here. Let's just do a quick label in case we forgot. So U1 is going to be our first term, N is going to be our term number, and D is our common difference. Make sure you guys can see that up there. Good. So find the 10th term of the arithmetic sequence using the formula. I'm going to rewrite it because I like to see it right above what I'm doing. We have UN equals U1 plus N minus 1 times D. Our first term is going to be 13. N, we're looking for the 10th term, so I know it's going to be 10 minus 1 times our common difference, which is 6, which is what we added each time. So you can pop that right into your calculator. I'm going to solve it this way. I have 13 plus 9 times 6. 9 times 6 is 54. 13 plus 54 will give me 67. So I have the 10th term equals 67. And that's good news because I can check to see when I added it and extended the pattern, I got 67 for my 10th term. And when I solved it using the formula, I got 67 as well. So I'm feeling pretty good about that one. Let's move on to my next pattern. So I have 193, 86. Here I'm trying to find the 15th term, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. By doing this, we're starting to see why the formula is so cool, right? So I'm starting, my first term is 100, then 93, then 86. What is my pattern each time? To get from 100 to 93, I'm going to take 93 minus 100 and see what I get. So I'm going to be adding negative 7 each time, or subtracting 7, right? Adding negative 7 and subtracting 7 are the same thing. So I'm going to do that each time. So I have 93 minus 7 will give me 86, hopefully, good. 86 minus 7 gives me 79. 79 minus 7 gives me 72. 72 minus 7 gives me 65. 65 minus 7 gives me 58. 58 minus 7 gives me 51. Minus 7 again, we get 44. That's my 9th term. Oops, I typed in minus 9 to my calculator, so minus 7. That gives me 37. 37 minus 7 gives me 30. Do that one more time. 23. For my 13th term, I end up with 16. For my 14th term, I have 9. And lastly, for my 15th term, I have 2. So let's check that again using the formula. So I have UN equals U1 plus N minus 1 times D. My first term is 100. I'm looking for the 15th term, so that's what I'm going to plug in for N. And my common difference was negative 7. So I'm going to have 100 plus 14 times negative 7. I'm going to plug that into my calculator. And I'm going to end up with 2. So U15 equals 2, which is exactly what you get when you expand the pattern. So I'm feeling pretty good about this one as well. Let's move on to the last problem, which is our ACT problem. So how many terms are there between 13 and 37 exclusive of 13 and 37 in the arithmetic sequence below. So this is a tricky one. Looking at this one, we see the arithmetic sequence. So there's two different ways we can do this. One of them involves writing numbers out. The other one involves the formula. So I'll do it both ways. We see here that our common difference is increasing by 3 each time, right? So basically, we want to know how many times we can add 3 between 13 and 37. So I'm going to do this. And then I'm going to count the number between. So 1, 16, 2. So again, this is counting the spaces between, because it's what it's asking for. How many terms are there between the two? So I'm going to count the ones between, not including 13 and 37. So 16, 19. The third one's going to be, what's 19 plus 3? I'm going to do that on my calculator. 22, 25, 28. Right? I was okay, good. 28, 31, 33. So that's 13, 37. Let's make sure I did this right. So 13 plus 3 gives me 16, 16 plus 3, 19 plus 3, 22 plus 3, 28 plus 3 gives me 31. 31 plus 3 gives me 34. There's my mistake, plus 3. And then to 37. So how many spaces did I have between? 1, 2, 3, 4, 5, 6, 7. So I know my answer is going to be 7. Good. The other way we can do this is we can say 13 plus, we know that our common difference is 3, so 3 times how many spaces? We can call that n equals 37. I'm going to subtract 13 from both sides. That gives me 3n equals 24. And n equals 8. 1, 2, 3, 4, 5, 6, 7. So if we're thinking about it this way, this is how many it takes to get to 37, but we don't want to include 37. So we need to subtract one more off. So if we do it that way, n equals 7 as well. Good. So if you have any questions about that problem, I know it was a little bit confusing, but I think solving it the spaces way makes sure that we don't have to think about subtracting one off after we solve. So this way makes more sense, right? Counting out how many spaces we're going to need, and you can get 7 both of those ways, though. Again, if you have any questions, come talk to me or Miss Avra, and we can answer any questions you have. Thanks, guys.